Today my topic is OpAmp. This is very important part in CSIRNet. I think all students who are going to sitting for the exam, this class is highly helpful to them. So I request all students to watch my entire video fully and please like, share and subscribe. I am discussing the topic OpAmp from basic concept. So this class is fully beneficial for all of the students. Means operational amplifier. It is a direct coupled amplifier with high voltage gain, high input impedance and very low output impedance. It can be used as to perform linear operations as well as non-linear operations. So OpAmp can perform linear and non-linear activities. OpAmp is designed to perform mathematical operations such as summation, subtraction, multiplication, differentiation and integration. The circuit symbol of OpAmp is this is minus, this is plus. So this is pin number 2, this is pin number 3 and this is pin number 6. So 2, this is the inverting terminal and 3, that is non-inverting terminal. So 2 is the inverting terminal and 3 is the non-inverting terminal and 6, that is output point. So this is 2, 3 and 6, this is the pin number. So V1, that is inverting input voltage, V2, that is non-inverting input voltage and V0, that is output voltage. Characteristics of OpAmp. An ideal OpAmp has some characteristics. Number 1, open loop gain is infinite. Number 2, input impedance is infinite. Number 3, output impedance is 0. Number 4, bandwidth is infinite. Number 5, when inverting and non-inverting input voltage are equal, that is V1 and V2 if equal, then V0, that is 0. So when inverting and non-inverting, when inverting and non-inverting input voltage are equal, then output is 0. Now come to the pin diagram of an OpAmp. So this is the pin diagram of an OpAmp. This is 1, this is 2, 3, 4, 5, 6, 7, 8. This is the 8 pins. So 1 and 5, in this 1 and 5 are offset none. Number 8, there is no connection. Number 2, that is inverting input. Number 3, non-inverting input. Number 4, that is minus V supply. And supply is given as a negative potential. And number 7, that is positive potential. And number 6, that is output voltage. So this is the configuration of pin of an OpAmp. An important problem in an op-amp circuit, the input voltage Vi 1 volt, the value of output voltage. So options are given. So input Vi, that is 1 volt, and two resistance, that is 1 kilo ohm, and we have to find out that is V0. So this is the circuit of inverting. So op-amp is acted as inverting loop. So we know that is in case of inverting loop, but in case of inverting op-amp, in the op-amp circuit, the input voltage Vi, that is 1 volt, the value of the output V0. There are 4 options we have to calculate with the help of this diagram. So this is R2, this is R1, and this is the Vi, that is input voltage. So here the op-amp acts as inverting amplifier. This is the inverting amplifier. We know the output voltage of inverting op-amp, that is V0 equal to minus R2 by R1 into Vi. So R2 is 1 kilo ohm, R1 that is 1 kilo ohm, Vi that is input voltage 1. So putting the value in this equation, we get the value of minus 1. So we get that is option C. Negative sign, here negative sign shows that the output is 180 out of the phase with the input. Here negative sign shows that the output is 180 degree out of the phase with the input. Next I come to the topic. Next, that is, there are next an important numericals is given. Here the circuit diagram is given, R2, R1 and input voltage is given. We have to calculate the output voltage. So output voltage we have to calculate. So solution, we know that V0 equal to 1 plus R2 by R1 into Vs. Here the op-amp acts as non-inverting amplifier. So this is the relation input and output in case of non-inverting amplifier. So R2 is given, that is 50 kilo ohm, R1 is given, that is 10 kilo ohm, Vs that is input voltage, that is 3 volt. Putting the value in this equation, we get that is V0 equal to 18 volt. So output voltage 18 volt, but the supply is given, that is plus minus 12 volt. Supply is given 12 volt, but we have got that is output 18 volt. Here op-amp saturates and V0 becomes very nearly to plus 12 volt. So answer will be, that is option A. So we have to remember that answer will be option A, because the output voltage the output voltage does not exceed the supply voltage. So we have get that is the answer, that is 12 volt, that is option A. Again, if Vi is 1 volt, then we get that is option, that is 6 volt. So we get that is option B. If here input voltage given is 1 volt and we get output 6 volt, then in this case we have get the answer option B, that is 6 volt. Next, calculate the output voltage of the OpAmp summing amplifier, that is adder, with 3 inputs are given, R1, R2, R3 are given, and also feedback resistance RF is supplied. So we have to calculate the output voltage. So this is the circuit of adder. So OpAmp acts as an adder. So this circuit, we know that is V0 equal to minus RF by R1, V1 plus V2 plus V3. Putting the value in this equation, so we get that is minus 4 volt. So minus 4 means we get the option, that is option A. So option A. Here input 100 kilo ohm feedback and capacitance and power supply given. Here input and power supply and also the capacitance are given. So we have to calculate. We have to first remember in case of integrator when the we have to first remember when the OpAmp acts as an integrator, the relation of output, that is V0 equal to minus 1 by CR integration, that is VDT. So putting the value, that is limit, we have get, that is 2 seconds. So lower limit 0, upper limit 2, and putting the value of Vi, so we get that is V0. Again we have to first calculate, that is CR. C, that is capacitance is given, R, that is given, so we have to calculate CR. So putting the value of CR, we get that is V0. So output gets saturated at minus 12 volt because the supply is plus minus 12. So since the answer is minus 20 but maximum supply, that is plus minus 12, hence we have get that is output minus 12 volt. That is a sinusoidal voltage Vs is given and differentiator circuit C and R also given, and we have to find out the output voltage. A sinusoidal voltage Vs is given and also given R and C. We have to calculate the output voltage. So this is a differentiator circuit, but this is a differentiator. So we have to first remember the output voltage, that is V0 equal to minus CR dVs dt. So putting the value of C and R and also Vs, we get, so putting the value of C and R, we get that is 10 to the power minus 2. Vs, that is input voltage given. So putting the value of CR and Vs in this equation, we get that is minus 0.1 pi cos 200 pi t in V. 200 pi t at a V volt. So this is the output voltage of a differentiator. Next, I come to the another problem. This is a circuit where R is given, C is given, output voltage given. We have to calculate the output voltage. So that is CR, C is given, R is given. We have to putting the value in this equation, we get the 1 second. So V0 equal to 1 by RC integration 0 to T Vs dt. Putting the value of Vs, we get that is V0 equal to 1 by 2 pi cos 200 pi t minus 1 millivolt. This is the answer of option A. Again we get that is differential amplifier. Again we get that is differential amplifier. It is defined as the amplifier which amplifies the difference of two input voltage. So V2 and V1 are the input signal applied to that is non-inverting and inverting terminal. So this is the inverting terminal, this is the non-inverting terminal. So non-inverting terminal, that is V2, and inverting, that is V1. So AD that is gain for difference voltage, that is VD equal to V1 minus V2. Average level, that is VC equal to V1 plus V2 by 2. VC is called common mode signals. So we know that is output voltage V0 equal to AD into VD plus AC into VC. Where AC is the voltage gain for the common mode signals. AC is the voltage gain for common mode signal. We have to know that is CMRR, that is common mode rejection ratio. CMRR, that is common mode rejection ratio. It is defined as the ratio of differential gain to the common mode gain, that is AD by AC. This is the CMRR. It serves as a figure of merit of a differential amplifier. Higher is the value of CMRR, better is the performance. CMRR is infinity for differential amplifier. CMRR, that is 20 log 10 base CMRR. So we can write that is 20 log 10 base AD minus 20 log 10 base AC. This is the relation of CMRR in decibel form. On CMRR, in a differential amplifier with two inputs is, that is 2.01 millivolt when the inputs are 110 microvolt and 90 microvolt, but the output is 2 millivolt when input are 10 and minus 10 microvolt. Find the CMRR of the amplifier. In the second case, that is VD we can get that is 10 and minus 10. So that is VD. Again we have got that is VC. So putting the value in this equation, we get that is AD. In the second case, that is we have, in the second case, that is AD is given. So in the second case, so we get that is AD equal to 1000. Again first case, that is VD that is V1 minus V2. So putting the value of V1 V2, and we have to calculate the VC. We know that is V0 equal to AD into VD plus AC into VC. So putting the value we get that is AC. So CMRR we know that is AD by AC. So putting the value of AD and AC, we get that is CMRR, that is 1000. Thank you. A differential amplifier has difference mode gain AD and CMRR, that is 1000. Find the output voltage for the input, that is V1 and V2. So we have to calculate VD. Vd equal to V1 minus V2. So Vc equal to V1 plus V2 by 2. We know that is CMRR, that is AD by AC. So we get that is AC. Putting the value in this equation V0, putting the value in this equation V0, we have to easily calculate that is V0. Next we have to know slew rate. Slew rate is defined as the maximum rate of change in output voltage per unit time. So slew rate, that is dV0 dt, that is maximum. It is expressed in volt per millisecond. In SI unit we can write volt per millisecond. It indicates how fast the output of an op-amp can change in response to changes in input frequency. So we can easily calculate in numericals an op-amp, that is op-amp output voltage changes 0 to 10 volt in 20 microsecond. Find the slew rate of an op-amp. So dt is given. So putting the value that is in the equation of slew rate, we get that is 10 minus 0 by 20, that is maximum. So 10 by 20, that is 0.5 volt per microsecond. So 0.5 volt per microsecond. So this is the value of slew rate. I think this class is highly helpful for the CSIR NET examinations. I think this class is highly helpful for CSIR NET students, and also this is very important topics for honors level. I think please like, share and subscribe to my channel, and please share the link of my channel. Thank you all my dear students. Thank you all my dear friends.